Okay, class, we're going to learn chapter 3. So in chapter 3, we're going to cover traffic management and control topic. So there is about three main subtopic for this particular chapter. Okay, I want to adjust my seat. Okay, we cover to traffic management, then parking study. The last part is on no motorized transport, which is for pedestrians and cyclists. Okay, what is traffic management? What is traffic management all about? Okay, it is a process adjusting or adapting the use of existing road system to improve traffic operation without resulting new major construction. I will highlight this particular uh, word. So please look at these particular words. Adapting, adapting or adjusting, existing. So we're going not to construct or do the new system, the new construction. Okay, that is the key that you're going to look into. Adjusting, adapting the use of existing road system to improve traffic operation without resulting major new construction. That is the management for the traffic. Okay, what are the objectives of traffic management? Okay, the objective of traffic management are easy traffic congestion. This is quite a major topic or major problem in urban transport. Enhance road safety. This also considered quite a major or main problems. Improve traffic flow in terms of the capacity. Okay, improve transportation people and goods. This kind of the option or model modes for transport. Reduce the impact of the traffic on environments, the pollution, emission, carbon emissions. Create a balanced model split. What do we mean for model split? So we have a category of the typical mode of choice or model. So if you look here, uh, even this kind of the 20 or 18 years ago in terms of the years, but still we can refer this kind of the concept or this kind of the proportion regarding model choose of the mode transport. Okay, first we consider as motorcycle, second is car, and third is bus, and fourth is rail. So in the middle 80s, it's considered public bus or public transport quite popular. Quite popular. It still can be the main option to travel, especially in urban or suburban area. But if you notice that in the late or 90s area or 90s era, okay, people going to own the vehicles. So if you count here, it's almost 70%. Oh no, 80%. People are moved to the private vehicles, and it's going to less using the public transport in the bus, mode of the transport. And also late 97s or late 1990s, so in our country they start to use or they start to introduce rail base, which is introduction of LRT, monorail. So these are the new mode of transport in the KL city center. and start from 2000 and onwards. So it seems uh, passenger car is most dominant in Kuala Lumpur city centre. That's why it caused a massive order congestion every day because there is a lot of the private vehicles. The number is increased in terms of the vehicle registration. And very less people using a bus nowadays. Yeah, the bus is still operate for service, but it very a few or limited numbers. And now the rail-based transport is take place to be a popular transport. LRT. Okay, we have monorail, ERL, or we have now MRT. Okay, next. Sorry, about the trouble. Okay, next we look the comparison between passenger car or private vehicles compared to others mode of the transport. Okay, here we have about 5 lane, which is occupy 177 cars that carry 200 people. Maybe some of these cars are sharing with 2 person, two passengers. If you use only bus, we only need a one single lane and 3 buses. This the physical layout of the travel lanes, highway travel lanes, without the car. So less capacity or less numbers of the people can travel within this particular lane. And if you use bike, so we need only to cover only one lane to carry same amount of the people. That's about the lanes balance model split. We provide more lane, but we create more congestion because people uh, going to use their own vehicles. But if we concentrate on the public transport or other modes of the non-motorized transport, it can create sustainable in terms of the transportation system. Okay, why we need to manage traffic? So we goes back to the problem in terms of the congestion. That's why we need to manage our traffic. High urban population growth result increase of vehicle ownership. We have discussed this one. Just discussed. The number of private vehicle automobile traveling in city is high, resulting traffic jams. You can see this particular scenario every day in the KL city center. Public transport is affected by jam. So even we try to provide public transport more, but yeah, they are suffer also because sharing the same infra or same route network unless they provide a dedicated lane for bus. Okay, conflict between private and public transport. Traffic jam occurs disruption of public transport services. Passengers are late for work, stressed out, exposed to fume, noise, and heat. Okay, criticism on new road construction. We noticed that some of the community society they don't want their within neighborhood area or their properties going to build some infra, so they don't want. Road network are extended to accommodate increased number of vehicles that I've said before. So we create demand supply, but it's not balanced in terms of the model smooth model speed. It does not solve a problem of traffic jam. It is government fund and cause scarcity of the land. Okay, others negative impact is environmental and health issue due to emission of the uh, emission carbon from the combustion engines. So it create the pollutions. So high energy from the fuel consumptions, exhaust fumes, heat, noise cause a pollution and health problems. Okay, mobility, accessibility, and safety problem to non-motorized road users. We know that yeah, most of the area in the city center they have kind of the non-motorized transport, especially for pedestrian and cyclists. So this user is find hard to traverse, access, intruded, and their safety at a risk. So this is the quite typical scenario. Okay, next increase travel cost. Okay, cost in terms of the money and time increase as more time is spent on the road due to the traffic jam. Yeah, because we stuck in the road, so we use some a fuel that take a lot of the time we spend. Then we produce more fuel consumption. So this some quite sarcastic things that they want to give some message to the combustion or yeah fossil based fuels.
As oil gets scarcer, gasoline gets more.
Okay, can you listen this sound? Can I? Okay, good.
As oil gets scarcer, gasoline gets more expensive, and the planet suffers. Electric cars? Most of their electricity comes from coal-fired plants or nuclear reactors. So what's the answer? How about a car that's good-looking, affordable, and runs on clean
Okay, ini sekadar sarkastik video untuk ya bagi mesej lah kepada ya company yang rakus buat apa ni ya, penggunaan fossil fuel berlebihan kan. More produce vehicle, we consume more resources from fossil fuel from petroleum and fuel from non-renewable resources. But nowadays people trying to use EV and energy efficient vehicles like hybrid car, solar car as well. Okay, what problem may occurs if the traffic not well managed? So yeah, we seem to be this kind of the scenario. Okay, traffic congestion, road accident, disruption of public transport, adverse effect on environments, safety risk for the pedestrian and cyclists, yeah, increased travel costs, using fund and land, yeah, a lot of the area going to use for the infra. Okay, traffic management technique. If you look at this, the the metric or the tables, it just simplify what category we're going to focus, and this is the category. We focus on input capacity, or we going to allocate the priority of road users, or we're going to constrain some categories of vehicles. Okay, let's move to the objective. If the objective is going to efficient of use of fuels, reduce of wastage, reduce of time wastage, which is delays, promote and develop urban economy. So we can use this kind of the technique or approach. Okay, if you focus on allocate priorities, so objective one, we're going to protect non-motorized road users, vulnerable which is from pedestrian and bicyclists. So increase effectiveness of higher occupancy. This one is focused for HOV. Later we're going to cover what is HOV, high occupancy vehicle, which is more passenger on the vehicles. Okay, next for the technique for this purpose, so we're going to focus on pedestrian areas or pedestrian precincts, cycle lanes, bus and HOV lanes, selective detection at signals, assumption for other regulation. So if you're going to restrain, do the restraints or kekangan pada to the certain vehicles. Why we want to improve public amenity or to protect environments or to improve safety. So we can impose this kind of the technique or methods. Parking controls, physical restraints, area licensing, road pricings, and traffic calming scheme. Okay, if you go to the details about the first one is link and improvement, junction or on street restrictions. Okay, this one is link and integration improvement. So this one we purposely, if you do this kind of the uh, method or approach, we're going to increase the capacity and enhance safety. Okay, reduce the delay and control the speed itself. So this is the generalizations. Okay, these are the normal traffic controls, and this one also normal traffic control. So I want to know about this one. Okay, anyone can respond to this one. What this kind of the facilities? Okay, if anyone can respond to this one, I will give 5 mark for topping any your assessment. Please respond to the chat section. What is these facilities? Okay, this one is we know as a cul-de-sac. Cul-de-sac. The function is going to have access to our driveway, our home area. Okay, next, create safe crossing for pedestrians, provide less waiting area, pedestrian refuse and shorter cross distance. So this is the typical pedestrian crossing areas. And this one also the crossing areas for mid block. They have a staggered. So because the lane number is quite many, so they have 4 lane, 4 lane to cross. So they have put a pedestrian refuge area, pedestrian refuge areas here. So cross the first lane or the first direction lane. Okay, just wait here to get some clearance or gaps, critical gaps or safe gap from the vehicles and cross again. Okay, now we have control speed and approach. So we have here net downs for particular approach intersections. So they built some here traffic islands or hard landscaping or dividers not dividers curb. The curb here and this one is the typical generalized or physical islands to choke or to net down this particular approach. So vehicle going to slow down. So here is parking load control implement on the main roads, especially during peak hours. So they put the sign here, no parking restrictions. Okay, benefit parking and loading restriction, relieve traffic congestions. Yeah, we're going to avoid people are waiting because of some vehicle try to unload the things or the passengers from the vehicles or the goods from the vehicles. Improve safety, improves visibility for pedestrians to cross, like this particular scenario, if they have a parking medium size of vehicle, lorry like such, lorry or utility vehicles, it's hard the pedestrian to cross because the blocking side distance. Okay, one on street parking restriction enforced provide sufficient off street parking. So if going to restrict this particular parking for facilities, we have to provide other option for off-street parking space. We're going to cover that on the second part lesson. Okay, designate load area, allocate for loading activities. Loading can be permitted only for the back lanes. This one, like a particular supermarket, they have their own access to the back area or rear area to load the good or the services. Okay, unless we're going to use this futuristics, maybe that nanotechnology like this one, it's quite impressive. If you have so nothing to worry about spacing for parking anymore. So we have, if we have this kind of the technology. Okay, one-way street also the part of the method. If you're going to control the traffic or the flow. Okay, advantage of using one street, reduce conflict point because we only have one street, one way moving or travels, so we don't have oncoming vehicles. So reduce a conflict point, increase capacity, yes, increase speed and flow, but be careful in terms of speed. It can create also the risk to the accident. Reduce the delay, yes, eliminate head-on collision because there is no oncoming vehicles. Eliminate diesels, eliminate easier for pedestrian to cross, because we're looking at one only directions. Okay, turning entry restrictions. Okay, we just provide some vehicle are not permitted to go right turn or left turn, or some vehicle is still not give permitted to you to do your U-turns. So we what kind of the sign to provide to inform that particular zone or particular movement direction is not permitted. Okay, contra flow, or tidal flow or river flow. What the scenario? We normally we have a quite massive traffic and during the peak hour or rush hour in the morning, let's say, in the evening. So some direction of travel lanes they're going to have very heavy traffic, while the other lanes is less traffic. So they're going to occupy one of the extra lane from the opposite travel lanes, opposite directions. So that's what they call contra flow. Contra flow is applied when there is imbalance direction distribution of the traffic during peak hours. So the traffic on the direction is while traffic on opposite direction is low. That's why they justify that they taken this not really usable to the other opposite traffic lane, because they less traffic, they're going to occupy this lane. Okay, when justify 90% more total traffic period in one direction. Remember this one directional distribution in our highway capacity. We have formula to determine DDVH. From there we apply formula AADT multiplied by K, and D is directional distribution that I mentioned, 35 or 45, 60 or 40. This one is over 65. One direction is can create this kind of the scenario. So this lane separated using barricade or channelized devices or provided proper signage, because we're going to occupy this additional lane from other direction. So I'm going to share one quite interesting video that practice this contra flow using their specific technologies. They call zipper divider. They create zipper divider to practice this contra flow the activities. So are we going to share now?
Okay, so in every traffic jam, don't we all wish there was at least one more lane?
Well, that's what drivers are getting this month on Interstate 15. New at 6 o'clock, 10 News reporter Joe Little explains why the extra lane won't last long.
It creeps along like a rolling centipede. If you blink while driving down the 15, you'll miss it. But if you slow down and focus, you'll see what Caltrans calls a barrier transfer machine. Normal people call it a zipper. It moves the concrete barrier dividing the express lanes one lane over.
It moves slow.
Really slow, like 8 miles an hour slow. But this monster of a vehicle could make the commute up and down the 15 much, much faster for the 169,000 people who use it every day.
It gives motorists more flexibility.
All month long, 2 zippers will be moving the center divide over 2 lanes. On a normal day, 2 lanes go each way, but this month, 3 lanes will go at the rush hour commute. Del Cerro resident Alexandra Brown already saves about 20 minutes using the express lanes.
If there was 3 lanes, that might help the speed of the commute.
But don't get used to it. Caltrans is only studying how well the zippers handle the 2-hour trek up and down the 15 twice a day in between rush hours.
We will be reconfiguring the lanes on a daily basis.
Then it will stop at the end of April. It will be up to Sandag, which actually manages the express lanes, to decide whether they want 3 lanes or only 2 for the rush hour commute. In the meantime, Caltrans wants you to keep an eye out for the barrier transfer machines. You can see in this video from a GoPro outside my 10 News Prius, the zipper is like a giant slow-moving vehicle in traffic. Whether they'll keep moving the barriers back and forth has yet to be decided. Along the 15, Joe Little, 10 News.
Let's take a closer look at the 15 freeway. This is where the lanes will be moved for the traffic. There will be concrete barriers from the 78 on the north side to the 163. There will be more lanes on the southbound side coming down in the morning commute, and on the northbound side, more lanes for the evening.
Okay, itu satu teknologi untuk kita praktiskan Contra Flow. The next, pedestrian segregations. Okay, pedestrian from the vehicle, separate pedestrian from vehicles traffic. We're going to avoid the conflicts. To reduce the pedestrian vehicle conflicts, enhance pedestrian safety, and to enforce no jaywalking. Jaywalking is mean the practice bad practice behavior. You just cross anywhere from the crossroad. It's not good. Okay, this kind of the scenario of pedestrian crossings. Okay, they only provide this particular area for the pedestrian. It's only no motorized transport at all. Okay, this one is normal guardrail to restrain pedestrian to cross this road, and also dividers, and also they provide the overhead bridge, and also the quite using the landscaping or just a nature, the natures sidewalk by planting by the planting the trees. Okay, these are the bicycle segregation. So we have bicycle lanes. They just do the extra additional lane, and they put the sign marking for the bicycle signs. So also they have in betweens. So there's also 2 lanes for the special exclusive lane for cyclists. So later we're going to cover on part 3 on part 3 for no motorized transport, including this one. Okay, next, bus and heavy occupancy vehicles. If you look, this one is typical bus lane, which is bus guidance or bus lane. They have a travels exclusive lane for the bus only, which is cannot be used for other vehicles. Okay, contra flow for bus lane. This one is they use the opposite direction for the bus travels. This one is guided busway or bus lane. They have a different in terms of the platform, and they put maybe this the walking area for pedestrians, and they provide a different height from the travelers. So the other vehicle cannot use this particular guided bus lane. Okay, high occupancy vehicles. Okay, they give a privilege for those that have high occupancy of vehicle passengers. Let's say two or more, that they can use this particular HOV lane. Only pool, that means your vehicle here having more passengers. So you have this kind of the facilities or the privilege to use this one. Okay, next, bus priority. Okay, smart intersection. Use bus detector to manipulate traffic signal which allow green phase for bus. So we have communication from the traffic signal to allow such vehicle like bus, emergency vehicle, rescue vehicle to give a priority during approaching the signal lines. So they're going to have a loop detector underneath the pavement, or they can put into the cable or street lighting pole or traffic signal pole to communicate the radar or the signal. Okay, traffic restraints. The type of traffic restraints measures. First, do nothing. Do nothing is part of the solution. Part of the solution. What is the approach? The approach is they give opportunity to the drivers to select the anything to be resolved. Driver eventually metric during off-peak hour, this sum of the resolve. Choose alternative of route and take alternative other modes transport. Yeah, because they do nothing, they want to study what the road behavior, road user behavior. But it's just for temporary. Okay, second, physical measures. Ban or prohibit entry or certain class of vehicle, like we impose the restriction for the turning bus lane, bicycle lane, like that one. Okay, regulatory measures. So we're going to impose parking, waiting loading area, or impose stiffer penalty if the regulation are violated. Okay, limit number the parking in the space city, impose higher tax for the parking operators. This in terms of the regulatory measures. Okay, the fourth one, physical measure, that we're going to use a financial approach. Okay, we put tax for the vehicles. Yeah, now they're practicing the tax for vehicles, the fuel tax. This one quite say road pricing and area rationing, which is we go to any road network, they're going to put the charge. Like this one in Singapore, electronic road pricing. We go there, we need to bring the auto pass, which is like smart tag or touch and go. It's also like practice for toll road. Road pricing typical like a toll road. But realizing is more like to the cover, for the cover, you go there and they will charge you. Sometimes they charge about the length that you travels, or they charge about the time that you enter, how long you enter that particular areas. Okay, next, traffic calming. Traffic calming involve the change in street alignments, install the barrier, and physical measure to reduce speed or cut through volumes, interest of street safety, streets, liability, and public purpose. So we have a lot of the traffic scheme. I think more than 16 type of traffic scheme, traffic calming scheme. Okay, but we can categorize as vertical deflection and horizontal deflection. So they only can be categorized as two, but they have a lot of the type. So the first category, vertical deflections, we have speed hump and speed bump. Okay, sometimes people quite confused to use whether speed hump, speed bump. Okay, speed hump, they have more wider compared to speed bump. Speed bump, they have narrow, but the effect of the vertical is not pleasant, but this one is quite smooth and feel quite pleasant. Dia ni berbonggol sikit lah, ni berbonggol sikit, ni landai sikit. Okay, speed lamp like just a panel with the rough textures, macam panel-panel lah. Okay, next we have speed table, also cover under vertical diffraction. Speed table more likely like crosswalk, race crosswalk, but more wider, compared to the speed table. Okay, speed table, speed cushions, quite similar with this one, the lamp, but this one they put just a small or the single lane size. But for the some small vehicle, maybe they can weave here. Okay, texture payment, they use some block individual, and they just install this one. And race intersection, which mean all the middle cross for the intersections in the center, they're going to build race elevation to give some effect reduction from the vehicles to cross this one. Okay, next we have horizontal. The first one we have vertical. This one is horizontal deflections. Okay, the first one traffic circles. Okay, this one traffic circle. Some you answer my the last question. Traffic circle. This one is traffic circle. It's quite small compared to the roundabout. Okay, this one roundabout, of course, they have a larger size compared to the traffic circle. It's quite small. Okay, they have the travel lane, which is 2 single travel lane or 1 single travel lane with the cross facilities for pedestrians. Okay, now next they have a chicane. The effect of the straight road to become like you have a cornering effect. Like you have a track for Formula One in the circuit. So they actually the road design is straight, but they want to give effect of the cornering, or like this road is not really straight, so they're going to create the effect. So they're going to extend it beside the shoulders. So this one they create the curve, the sway curve, or they just do the traffic islands for here to make it the road looking as a corner effect. The next net down. This one is typical. We just discussed previous. They put a narrow width of the lane, so the effect of the islands here, also here, they practice quite typical. But not down, approaching the section, the choker along the straight travel lanes. Okay, this one central islands. So they're going to split to be not a straight road without any barrier. You just create a small island here to give effect. We have to alert some part need to provide the crossing for pedestrians. Okay, this access point management. So some of part the location of the main road directly access to the driveway. So this we call driveway. It's not good practice because the speed relativity is quite high. Yelah, keluar pada rumah slow kan, masuk rumah pun slow. Sedangkan this the main highway is high speed. Macam laluan di F015 ni lah, depan kampus kita kan banyak rumah-rumah tu jalan kan. This is not good practice because they do the upgrading road. So if you want to plan the new road, it's supposed to be like this. So this the highway or the main road. So going to the housing area, they're going to have a service road and the access from the service road. Not here, directly join the driveway to the main road. So as enforcement law to be practiced, okay, speed limit and speed zone is quite typical enforcement to put road traffic zones in the school area or certain area we have limit the speed zone. Like our area in Pariraja to the street guarding 60 km per hour. Going to Itam, some got 90 km per hour. Depend the land use areas. Okay, managing heavy vehicle, good vehicles. Okay, heavy good vehicle nuisance to the traffic, cause the damage to the road pavement and structure of the road, impedes the traffic. When the involved accident, it cause serious injury and damage. Yeah, this is the scenario, the effect or the consequences of the vehicles. Okay, area wide heavy vehicle management scheme. So they allow to use some special provision to entering passing area for road sections. Okay, highway cordon used to prevent movement or still permitted access. Sometimes they just limit, just sometimes they just give the access. Okay, off travel for HGV. So I think during couple years or 10, 5 years ago, government also give some limitation to heavy good vehicle to travels during the peak hour, especially on festive season. Cuti hari raya kan, kita ada sekatan kena berat. Macam ni lah keadaan dia. Okay, loading restrictions. Ini pun kita dah bincang tadi. Okay, providing for public transport. Okay, encourage use the public transport, the best solution to reduce the congestions. Okay, sebab dia ada problem kalau we going to serve the public with the public transport, but somehow this quite typical scenario the problems inadequate services during peak hour, kurang kenderaan pengangkutan awam overcrowding, small size and or crowd and with the passengers, delays and inconsistent schedule ni normal tunggu lama memanjang nak dapat kenderaan awam. Transit facilities are deplorable states. Benda tu pun kadang-kadang jauh tempat untuk pergi ke transit facilities or terminals. High fare for poor service, journey is too long. Tapi journey too long ni depend kalau ke perjalanan is comfort okay. If the journey is not really comfort, it gives suffers. So this the typical practice, especially in advanced countries. They provide bus transits, busway, bus lane, bus streets. Okay, LRT, this rail-based. This is bus type. LRT, monorail, express, rail transit, bullet trains, or MRT nowadays we have. Okay, others we have to improve transit facilities. Okay, this is quite typical. Quite typical in terms of the facilities for public transport. So here they have a bus, normal bus. So here they have a bus priorities. Okay, bus rapid transits. This is quite small one, but I will show you the large bus transit system. This is the intermodal. You're going to move one public transport to other public transport from the bus. You're going to use these trains or commuters. Okay, now I want to share you video clip on bus rapid transit in Colombia. Quite successful his experience. So the first the Prime Minister some of the recommendation they're going to use elevated highway lebur yang bertingkat to cater demand from the traffic but they scrap that project, they replace with the BRT. They are not going to construct anymore the highway facilities because they have a scarce situation into the mass congestion. So they put new idea to introduce BRT. Then they give a lot of benefit to the public and their community. It's very good successful story. I think you can enjoy this clip.
At the end of September, I went down to Bogota, Colombia with Clarence Eckerson from Street Films, Carla Quintero from Transportation Alternatives, and actually Ethan Kent from Project for Public Spaces was along for the ride as well. We were taken around by Guillermo Gil Peñalosa, who is the brother of the former mayor Enrique Peñalosa. And he gave us a great tour. We saw all of these incredible urban design innovations that the city of Bogota has been working on for the past dozen years or so. And it was really impressive. We got to take a look at that city's bus rapid transit system, which is called Transmilenio. About 10 years ago, when Enrique Peñalosa became mayor, there was a plan on the table to build a network of elevated highways all throughout the city of Bogota. It was incredibly expensive and multi-billion-dollar project. And Peñalosa and his administration looked at this project and said, this isn't going to do anything actually to solve our traffic congestion problem. It's going to create huge negative environmental impacts on the city as a whole. So Peñalosa decided to scrap that project and instead, for a fraction of the cost, replace it with what I think still today is probably the world's most advanced bus rapid transit system.
Tell us what is Transmilenio?
Transmilenio is a bus rapid transit, an economical model specially developed to operate in Bogota in the main corridors, with the objective is to give a segregated lane, exclusive lane for big buses, in order to the people can move very quickly, but with 10 times less the cost of the traditional mass transit system in the world.
Some people call it surface subway. And you could kind of see why. It's buses on rubber wheels, just like you'd see buses in New York. But what you see they've done is, like, in the middle of these busy multi-lane avenues, almost highways, they've taken away a couple lanes in the middle and they've built these stations. And next to the stations, you'll see usually 2 lanes of buses running on either side. You have a lane for local bus traffic and for buses to pull into the station, and you have another lane for the express buses. The buses pull right up to the platform so that the floor of the bus is level with the floor of the station. So it's really easy for wheelchairs and older people and people pushing strollers to get on and off the buses. I got to interview the CEO of the Transmilenio system, and she's someone who was there from the very beginning of the system and kind of worked her way up.
Before Transmilenio in 1998, one trip of 30 kilometers can be done in 2 hours, 2 hours and 15 minutes. That same trip, you can do it today in 55 minutes.
And how many people are you moving every day?
Around 1.3 million people per day. I think nobody believes in Bogota that we could change the way to transport our people, because since 1947 we start doing some studies, 50 years trying to do some things about this, but nobody says we are going to do it.
They took us on a tour of the Transmilenio control room. It was almost like air traffic control, and in fact that's how they compared it. There's 6 different companies actually own and operate the buses themselves. How many buses are you guys controlling in here at rush hour?
In a peak hour, like 1,000.
You have a sense of an average speed?
28 kilometers per hour in average. But we have lines of near 40.
Wow. This central hub that we visited dispatches the buses. It follows them around the city in real time. They can communicate with drivers individually. You see a photo of the bus driver pop up on the controller's computer screen when he's getting ready to talk to that guy. They can see if buses are starting to bunch or stack up together. Most of the Transmilenio system are these double long red buses, but Traveling around through city neighborhoods, you see these much smaller green buses, and those are called feeder buses. And then what the feeder buses do is they travel through neighborhood streets and pick up people and take them to the bigger bus stations. One of the interesting things about the green feeder buses is that they're free. You don't pay for your Transmilenio ride until you get to the bigger bus station. That's one of the things that really speeds up the loading and the unloading, kind of like the subway in New York. You're paying for the bus in the station rather than having to pay the driver and wait for everyone else to pay the driver. One of the most impressive sort of intermodal transportation features that we saw while we were in Bogota was this bike parking facility inside of a bus station.
For the Transmilenio system, it's very important the integration between transportation means. We have today 3 terminals and 1 station with bike parking facilities. In this case, we're in America's terminal. This parking facility has 750 capacity. It's very safe. It's a good feeder system for the Transmilenio, and it's for free.
Nosotros compramos la tarjeta de Transmilenio para ingresar. Pasamos por la registradora y dejamos los datos ahí. Nosotros nos dan un stickers con un número de identificación de la bicicleta. Nosotros damos el nombre y el sticker y siempre nos preguntan a la salida y a la entrada.
Hay veces que el Transmilenio lo utilizo 4 o 5 veces en el día y es el mismo trayecto. Me vengo en bicicleta y me voy en bicicleta. Para mí es bueno.
They believe that for every 20 people they can get to bike to the bus station, that's one less of these green feeder buses that they need to operate. And that saves the transit system a lot of money. So for Bogota, bicycles are a really critical part of the mass transit system. One of the things that's really striking about Transmilenio is all times a day, it was just packed. I mean, almost if there's a
Oke, itu BRT di kota Bogota, in Bogota, capital city in Colombia. So they have a lot of the system that incorporate with the BRT. They give feeder bus, free feeder bus to intermodal, and then also facility for cyclists to park their vehicle, over there in the special area with the free. If they purchase the ticket for the BRTs. So this is my experience using quite prominent public transport in Ambak country. This the time I went to Germany. So this is the ICE, quite fast, high speed rail in Germany, which is ICE. Okay, the top speed is 350. But during my travel, I just noticed that the top speed is 280 km per hour. So these are the sky trains. They also the free facilities. You going to the mini airport, I think in Düsseldorf. I went to the Düsseldorf, and we just park our vehicles and take the sky train to the mini airport in Düsseldorf. And this is the quite typical tram in city for the small size. They have with the 2 coaches for the tram and share the lane from the normal traffic. Okay, others is active traffic management system. Okay, active traffic management system can be defined is dynamically managing the traffic control based on prevailing conditions. So we have some quite not really advanced, but sometimes they have dynamic in terms of the facilities. So like speed harmonization, queue, warning right metering, dynamic messaging sign, temporary shoulder use, automated enforcement, reroute, traveler information, dynamic lane marking, and travel time signs. So like this one. So instead of using a typical traffic sign, but you use the digital one to give some the changing or dynamic of the information. This one they stick with 70, this one they stick with 80, but sometimes they can change. They want to be 70 or this one to be 80. Okay, this one give information the queue 1 mile ahead. The information going to be dynamic, change anytime. Okay, this one is rank metering. The vehicle going inside to the going to join the highway from the on ramp. So sometimes they quite heavy traffic flow. So they're going to stop a few vehicle queuing, and after some time release in terms of the gap, into the flow. So they're going to give a green time to other vehicle access to the ramp and join to highways. Okay, this is a dynamic machine sign with the info here. So showing the road works or accident or any conditions. Okay, this one is temporary road shoulders. So you know we are not permitted to use road shoulders just for emergency situation. But this kind of the operation they gives a temporary during a massive congestion they give a temporary to use these shoulders. Okay, this one is implemented in our country. Even this is the view of pass highway. Okay, automated speed enforcement. Okay, dynamic reroute travel information. This one, they're going to give some additional info for travel times. So using this route, 9 minutes. Using this route is 12 minutes. Okay, this one is just a delineation for lane marking to improvise lane marking. Okay, travel sign, time sign. Okay, also this put like travel expected arrive time ETA. Okay, also in Malaysia we do have this kind of the facilities. We call it intelligent traffic management system. Specific name, integrated transport information system or ITIS. So this only specific on KL City Centre. So ITIS that cover for Kuala Lumpur or Lembah Kelang only. So it's not cover for whole nation, but specific for under jurisdiction of DBKL. So there are three part of ITIS. So the first is traffic situation to monitor. So they're going to use CCTV camera detector to surveillance the traffic conditions. So then they move to advanced traffic management system. They gather the data and they're going to pass to the traffic management center. So they're going to analyze the situation. So now they can do the mapping of the traffic conditions or any incidents. Then they're going to disseminate the information using various or variable in platform where in the internet, call center, and also using a specific VMS or messaging at the particular route or section. Okay, I will share this video later on the FOC activity, but not now. I think we're going to cover this one for FOC activity. But don't worry, I will upload this video and you can go through the video and enjoy the video while do some, I think, add puzzle activities. I think that's all for today's lectures, because I'm not going to cover the topic for parking. It's quite extensive and have some calculation part. So I will stop at this particular lesson today.